So welcome back to the part 2 on unique normal vector. So in the previous part, we've looked at the formula to calculate the unique normal vector, and we looked at one example. So here is the example 2 under unique normal vector. So the question says, determine the unit normal to the surface xyz plus x square y minus 5yz minus 5 equals to 0 at point 312. So let's do this. So if you've been following the video series from the beginning, you might just want to pause this video and just attempt this just to test your knowledge, your understanding so far on the topic unit normal vector. So can you just pause the video, attempt it, take note of your answer, and then put it down in the comment section. Alright, so I hope you've just done that and then you have your answer on standby. Alright, but however, let's do it together. So again, I'm going to be writing out the formula just to make sure that I carry everyone along. So the formula for unit normal vector is giving us as grad phi. Let's say phi is the function over the magnitude of grad phi. Are we good? So from this now, that means the first thing we are going to need to calculate is this, exactly, which is the grad of the function. So this is the function already. And then for us to calculate the grad, so don't forget the formula again. So there is the formula. Okay, so now let's start to do it one after the other. So I'm just taking out time to do this so that just to make sure that I carry everyone along. All right, so let's differentiate the function this. So this is our function. So let's differentiate it. Let's look for the partial differentiation with respect to x. So doing that, we're going to be having yz. So that means if you start with this, so we're having yz plus xy. Sorry, that will be 2xy here, because if you differentiate x squared, that will give us 2x. So for this now, it's going to be 0 because there is no x here, and this is also going to be 0 because there is no x there. Okay, so that is for the first one. So now let's go to that of y. So for y, we are going to be having, so the first one we're going to be having here, we're going to be having xz and then x squared minus 5z. Are we good? All right, so I want to believe by now you already understand how partial differentiation works. So like I said, xz plus x squared minus 5z. Okay, so don't forget, so this is going to be j. And then for the first one we did earlier, this would be I. Okay, so now let's do for partial differentiation of 5 for that of z. Okay, so let's look at for that of z. For z, this is going to give us xy plus this will be 0 because there is no z here, and then this will be minus 5y, and this will be 0. Okay, so let's go and put that down. So we are going to be having xy minus 5y, then our k. Okay, so don't let us forget, the question says at the points 3, 1, and 2. So that means, so you can see at point 3, 1, and 2. So just like the previous example, so what that simply means that our x is 1, is 3, our y is 1, and our z is 2. So now let's put in those values into this 3 that we have here. So let's start with this. So yz, that's going to be 1 times 2 plus 2 times x is 3 and times 1. So this would be 2 plus 3 times 2, 2 times 3 times 1, 6, and that would give us 8i. So for this x and z, so this is going to be 3 times 2 plus x squared, that's 9, minus 5 times 2. Exactly, so we are going to be having 6 plus 9 minus 10. So 6 plus 9 minus 10, that will just give us 5. So that will be 5j. And then for this, it will just give us x times y So that's 3 times 1 minus 5 times y. So our y is 1, that's 5 times 1. So this will give us 3 minus 5. So that will give us minus 2k. Alright, or just 2k. Okay, so we can conclude that our grad file is 8i plus 5j minus 2k. Okay, and then the next one is to look for the magnitude. So that's going to be, and that will give us 8 square plus 5 square plus minus 2 square. So you can just put 2 square also, it will still give the same value, but just let's put in the right thing here. Okay, so this will give us 8 square is 64 plus 5 square, that's 25, plus minus 2 square will give us 4. So if you put this together, 64 plus 25 plus 4, and that should give us square root of 93. Okay, all right, so now we can go ahead and write out our unit normal vector. So our n, which is giving us the grad of file over magnitude of grad of file, can now be written as, don't forget we've gotten this value earlier. So that was the first thing we calculated, which is this. So let's come and write it, which is 8i plus 5j minus 2k over this, which is, remember this is this, so square root of 93. So we can just write it to make it looks better. So we are going to be having 1 over root 93, then in brackets 8i plus 5j minus 2k. All right, so what we are having right here now is our final answer to the question. Okay, all right, so that's the solution to the question. So just in case you still don't understand, go ahead and watch the part 1, come back and watch the part 2, then you can maybe watch it 1 or 2 times so that you can just understand it. I've explained it as simple as possible. But if you have any question or any doubts, don't forget, just leave them in the comment section. And again, if you find value in it, please give it a thumbs up. And if you are yet to subscribe, please kindly click on that subscribe button. So that's it on unit normal vector, and I'll see you all in the next one. We are still dealing with grad, call, and div. Thank you.